Hi everybody, this is Mrs. Lehman from Math with Mrs. Lehman. Happy Friday. Today we're going to do review session 9. The first question says, which pair of expressions is equivalent for any variable value greater than 0? So we're looking for two expressions that once we combine like terms, use the distributive property, whatever we've got to do, they will come out and be exactly the same. So the first one, test your knowledge of the distributive property, and it kind of plays on the big mistake that kids make of not multiplying that number on the outside of the parentheses by both terms on the inside. So you would get 3x for your first term, but right here that should have been a 6, right? Because 3 times 2 is 6. So that is an incorrect choice. Let's look at B. We have 4D plus 2E. Well, that expression is definitely not equivalent to 8D plus E because we're adding those two quantities and you cannot combine them in any way because one is dealing with D, the other one is talking about copies of E. So choice B is a bad answer as well. Choice C says F plus F plus F plus G and 3FG. So this would be 3F, but we're adding another G. So that is not the right answer. Let's look at choice D, which hopefully is the correct one. So we have B plus B, which means we have 2 copies of B, plus 3C. And again, we can't combine these because they are not like terms. So our correct answer is choice D. Okay, let's move on to the next question. Question 2 involves the same skill set. It says the two expressions below are equivalent. So again, we have to use the distributive property and to combine those. So they already kind of did this for you. This question is more about the why they're equivalent and what makes it a true statement versus actually doing the distributive property here. But anyway, so you would have 2.5y plus 7 times y would be 7y. Plus another y minus 2. So when we combine this, this, and this can all combine, right? So that's going to add up to 10.5y, and then we have minus 2. So it says, which statement best explains why the expressions are equivalent? Choice A says the expressions have the same value for any value of y. So that means we could plug in any single number and it would work out all right. B says the expressions have the same value for only whole number values of y. That is not true, all right? Because we could plug in a decimal, we could plug in a fraction, and it would work just fine. If two expressions are equivalent, they're equivalent all the time. All right, so we could plug in any value as long as we're consistent to both expressions. Plug in the same value in the top and bottom expression here. You would get the same result. All right, the correct answer is choice A, but let's look at why C and D are wrong. It says the expression for C have the same value only when y is an odd number. That's not how we differentiate these. Nope, they're equivalent all the time if they're equivalent. Choice D, the expressions have the same value only when y is an even number. Again, not the case. Okay, so when expressions are equivalent, that means they have the same value when you plug in a consistent value for, in this case, y. All right, so that's a question where a lot of kids are probably gonna, if they get that wrong, it's because they didn't read carefully or they just got lost in the terminology there. So let's move on to the next one, maybe. All right, it says the diagram below shows the percentages of people attending a football game. Sorry, I thought I skipped the page. Attending a football game who were supporters of either the home team or the visiting team. And it says supporters at the football game and visiting team, it's 20%, and the home team had 80%. And then let's scroll down a little bit. If the total number of people attending the game was 64,000, how many people were supporters of the home team? So we know the total, that means both the home and the visiting team, and we want to figure out supporters of just the home team. So let's take a look at something you learned in Module Module 1. I am struggling today. It's been a long week, guys. Part over whole equals percent out of 100. So what we're going to do is type in. We're not typing anything. Wow. We are going to write in what we know. And we know the total number of people was 64,000. Okay? So that's 100% of everyone who showed up. All right, and we also know that the home team was 80%, right? So we're looking for what is 80% of this number right here. So one way you can do that is with a proportion. Obviously, we're going to need to simplify first. Well, actually, not obviously. We could. We don't actually have to because it's such an easy number to go in there. Again, having a hard time. All right, so if we're seeing how many times we have to multiply 100 to get into 64,000, right? We would do that when you divide 64,000 by 100. That means we're multiplying 100 by 640. Because again, you would tack 2 zeros on the end. That would give you 64,000. So we're going to take 80 and multiply that by 640 as well. So 80 times 640, you're going to have 200. 8 times 4 is 32. 8 times 6 is 48. Plus 3 is 51. So 51,200 people were the home supporters. And then, you know, the difference between that and 64,000 would be how many visiting team supporters there were. But we're looking for home supporters, so home team supporters, so that would be choice D. Right? Another way of doing this would be, we know that the home team represents 80% of 64,000. So when you're finding percent of a number, you're going to take your percent, turn it to a decimal. So 0.8 would be 80% as a decimal would be the same as 0.8. You take 64,000 and multiply it by 0.8. All right? So you get 0, 0, 0, 8 times 4. I'm going to erase some stuff because this is kind of a jumbled mess here. Maybe. All right, so clean that up a bit. All right, so 8 times 4 is 32. 8 times 6, 48 plus 3, 51. Now, we have this one decimal spot here, so you start at the end, move it in 1. Put our comma here, so 51,200 people. So there's more than one way to get there, but it is choice D, and I believe that's our last question. All right, so the challenge question is, what is the least common multiple of 8 and 12? What is the LCM of 8 and 12? All right, guys, really have a great weekend. I know it's been a long week for all of us, especially with, you know, 2 marathon days of ELA testing, which, again, I can't stress this enough. I am really proud of how well everyone on my team did. Truly great work. Enjoy the weekend. Have a great day. I'll see you on Monday.